Imagine you are floating in absolute darkness. No stars. No sound. No reference point to tell you which way is up or down. Just an endless, cold void pressing against you from every direction. And then, slowly, something begins to glow. It starts as a whisper of light. A faint amber smear bleeding through curtains of dust so thick they swallow entire star systems whole. But as your eyes adjust, the scale of what you're seeing begins to register, and your mind struggles to contain it. Two enormous wings of glowing gas stretch outward like the lobes of an hourglass, each one larger than 100 solar systems placed end to end. At the very center, pinched between those wings like a secret held between two hands, a razor-thin disk of swirling matter hangs in perfect, terrible silence. You are looking at a star being born. And 4.6 billion years ago, give or take a few million years, our own sun looked exactly like this. This is L1527. A protostellar system embedded deep inside the Taurus molecular cloud, 460 light-years from Earth. And what the James Webb Space Telescope found here, buried inside that disk, written in the language of molecules, has just rewritten everything we thought we knew about how our solar system began. To understand why this discovery matters, you first need to understand the scale of what you're looking at. Those two glowing lobes, the wings of the hourglass, span 4,400 astronomical units from tip to tip. 1 astronomical unit is the distance from the Earth to the Sun. So stretch that distance out 4,400 times. Now understand that both wings of this structure are larger than that. If you place the entire architecture of our solar system, every planet, every moon, every ring, inside a single lobe of L1527's hourglass, it would disappear like a coin dropped into an ocean. At the center of all of this sits the protostar itself. L1527 IRS. It has not yet ignited. It is not yet technically a star. It is a collapsing knot of gas and dust still in the process of becoming, and it is only 100,000 years old. In a universe that is 13.8 billion years old, that makes this object by every meaningful measure, a newborn. But here's the thing. That razor-thin disk cutting through the middle of the hourglass? Webb's instruments detected something inside it that stopped scientists cold. Carbon chains. Complex organic molecules. Water ice. The precise chemical fingerprints of planet formation, and not just any planet formation. Our planet formation. The same molecular inventory that was present in the primordial cloud that collapsed to build the Earth, the oceans, and eventually, us. But here's the problem. That disk should not still exist. The environment surrounding L1527 is not peaceful. It is not the quiet nursery the glowing imagery might suggest. It is, by almost any measure, one of the most violent environments in the known galaxy. The protostar at the center of that disk is still accreting, still pulling infalling material down onto itself at velocities approaching 400,000 kilometers per hour. Every time a wave of gas slams into the protostar's surface, it generates a burst of radiation powerful enough to strip the chemistry from the inner disk in hours. X-rays, ultraviolet light, energetic particles screaming outward in all directions. If you were standing at the outer edge of that disk, shielded somehow from the cold, the radiation from that single collapsing object would be equivalent to sitting inside a particle accelerator with no walls. And from both poles of the protostar, twin jets of ionized plasma are being launched outward at a fraction of the speed of light. These jets are what carved the hourglass shape in the first place, drilling through the surrounding molecular cloud, pushing it aside, sculpting those luminous wings. They are not a side effect of the formation process. They are a pressure valve. Without them, the energy building up inside the protostar from all that infalling material would have no escape. The system would overheat. The disk would be destroyed. No planets. No chemistry. Nothing. Webb's NRCam imagery revealed something troubling about those jets. They are not symmetric. One lobe burns brighter than the other. The structure is uneven in ways that no current formation model fully explains. And that asymmetry, small as it looks in the images, is a symptom of something far more disruptive happening underneath. Because it is not just the jets causing problems. There are layers to the danger here, and each layer is worse than the last. The protostar's magnetic field is woven through the spinning disk like invisible thread, and it is actively working against the disk's survival. A process called magnetic braking is siphoning angular momentum away from the disk, causing material to spiral inward faster than it should. Faster inward spiral means faster accretion. Faster accretion means more radiation. More radiation means more disk destruction. And then there is the disk wind. Webb's MIRI instrument detected molecular material being launched off the disk surface itself, not from the jets, but from the disk directly. The disk is not just being attacked from above and below. It is evaporating from the inside out, launching its own mass into space like a slow bleed that never stops. By every model scientists had built before Webb, this disk should have been gone 50,000 years ago. Evaporated, scattered, reduced to nothing. And yet here it is, still spinning, still intact, still carrying its cargo of complex chemistry through one of the most hostile environments in the galaxy. Something is feeding it. A vast cold envelope of molecular gas, the remnant of the original cloud that gave birth to the protostar, is still raining down onto the disk at roughly 1 Earth mass per year. This is the disk's lifeline. Without that infalling material replenishing what is being lost, the disk would have collapsed long ago. But that same infalling gas is also the disk's greatest threat. Material arriving at the wrong angle can warp the disk's geometry, tilting it, bending it, twisting its orbital planes into configurations where stable planetary formation becomes impossible. Most young solar systems in the galaxy end exactly this way. The disk warps. The orbital geometry breaks. No planets form at stable distances. And if any world does manage to coalesce from the chaos, it does so in an environment where the chemistry was disrupted before it could seed anything meaningful. Our solar system did not end that way. And Webb is now showing us, in extraordinary detail, exactly how close the margin was. Here is how the physics actually works, and why it leads to the most astonishing revelation this telescope has ever produced. When a molecular cloud collapses under its own gravity, it does not fall inward uniformly. Because the cloud was always slowly rotating, even at just a fraction of a degree of spin, as it contracts, that rotation accelerates. Think of an ice skater pulling their arms inward. The faster they pull, the faster they spin. The collapsing cloud behaves the same way. The rotation speeds up as the material falls inward, and that centrifugal force flattens the infalling gas into a disk rather than allowing it to pile directly onto the protostar. That disk then stratifies itself by temperature and chemistry. Close to the central object, where radiation blazes and temperatures exceed 1,000 degrees, only silicates and metals can survive, the raw ingredients of rocky worlds. Further out, where the temperature drops below the frost line, water freezes. Methane freezes. Complex organic molecules, the kind that chemistry textbooks list as precursors to biological processes, survive intact, frozen in the disk like messages in a bottle. And this is where Webb's discovery becomes something that stops you breathing. Using its MIRI spectrograph, an instrument sensitive enough to detect individual molecular bonds across hundreds of light years, Webb identified cyclopropenylidene, acetylene, and several other carbon chain molecules inside L1527's disk. These are not random chemicals. These are the specific precursor molecules found inside the carbonaceous chondrite meteorites that fell to early Earth. The meteorites that many scientists believe delivered the chemical seeds from which biological molecules eventually emerged. The molecules in L1527's disk are the same molecules in your body. Not similar. Not analogous. The same. Assembled by the same gravitational process. Preserved in the same cold outer disk. And Webb found them fully formed and intact at just 100,000 years of age, before the disk had even stabilized. Before a single planet had begun to grow. Before Webb, we had glimpsed L1527 through the Spitzer Space Telescope. Spitzer revealed the hourglass. It showed us the shape. But Spitzer's resolution was too limited to see inside the disk, to read what was written there. Scientists suspected L1527 was significant. They could not yet prove how significant. Webb changed that in a single observation. With its 6.5-meter mirror cooled to within 40 degrees of absolute zero, it resolved the dark lane of the disk cutting through the center of the hourglass with a precision that made the images look almost unreal, a razor-sharp shadow against a background of fire. And inside that shadow, the chemistry of an entire future solar system was already waiting. This is what makes L1527 almost unbearably rare. It is a Class 0 protostar, the earliest and most short-lived phase of stellar evolution. Its disk phase will last at most a few 100,000 years before the infalling envelope runs dry and the disk disperses. In a universe 13.8 billion years old, that is statistically invisible. Webb arrived here during the single most informative moment in L1527's entire existence. A coincidence so improbable it feels almost deliberate. And so we return to the hourglass. You are floating before it again. The same glowing wings. The same dark disk. The same silence. But nothing looks the same as it did before. That hourglass is not just a beautiful structure. It is a record of creation writing itself in real time. The jets carving the lobes. the disk preserving the chemistry, the molecules waiting, patient and intact, for the gravity that will one day press them into planets, into oceans, into atmospheres, into something that breathes. Somewhere in this galaxy, right now, a version of this process has already finished. A disk that once looked like L1527 has long since dispersed. The planets it built have cooled. Water has pooled. Something, we do not know what, we cannot yet know what, has looked up at its own star and wondered where it came from. The answer was always in the disk. Always in the hourglass. Always in the molecules assembled by gravity and cold and time in a stellar nursery no different from this one. We are not at the end of this story. We are an early sentence, written in the same ink by the same hand, in an account of the universe that is still being composed. The hourglass is still turning. And Webb, for the first time in human history, has let us read what is written inside it. The universe does not keep its most beautiful things forever. But sometimes, just sometimes, it lets you watch while they are still becoming. If this video made you feel something about the scale of existence, subscribe, because Webb is rewriting the textbooks faster than anyone expected, and every chapter deserves this treatment. The next one goes even deeper.